Hello, hi, this is Dr. Wei. Today we're going to do the experiment on separation by extractions. All right. So first, what we're dealing with. So I have a jar of 1:1 mixture of benzoic acid and para-dichlorobenzene. All right. The goal for the day is to use the technique called extraction to separate the two compounds away from each other. All right. So that's the goal. In terms of major device we're going to use is separator funnel. All right, that's the major device for the extraction. So I have a separator funnel right here. Make sure it's closed at the bottom. I pour 30 mils of methylene chloride, which is an organic solvent, inside the separator funnel first, and then I need to add in 2 grams of this solid mixture into separator funnel. Okay, 2 grams. So I have a balance in the back. Can you guys see it? Yeah, it's in the camera. So I need to measure 2 grams out. So this is the wax paper, right? Typically a triangle, square. I fold it along the diagonal, form a triangle, and then from the top of the balance, waiting for the number to stabilize. I press 0. All right. Time. Now 0, 0. Now I need 2 grams. Grab a spatula. Taking 2 grams exactly out. All right. 2.00 exactly. So 2 grams of the mixture. I'm going to bring it over here. Now it's to the point of folding, right? It's easier to transfer and also easier to transfer into the separator funnel with the sharp tip or any other glassware. All right. Now I'm going to swirl a little bit, try to dissolve as much as I can. But it doesn't matter what I do, it's not going to be fully dissolved. Which just makes sense because para-dichlorobenzene, of course, it's going to dissolve. However, the polar benzoic acid, it's going to have a hard time. So, in order to dissolve the benzoic acid, we need 10 mils of 5% sodium hydroxide. So, 10 mils. All right. I have a 10 ml graded cylinder measuring 5% of sodium hydroxide aqueous solution. All right, here we go. So I just added 10 ml of 5% sodium hydroxide. So now flip it over, vent, always vent, and then shake, vent, shake, vent, shake, vent, shake, and vent. Do that like 3 or 4 times. So there's a chemical reaction here, right? Benzoic acid, even though it's a weak acid, but still reacts with sodium hydroxide aqueous solution. Actually, this is one of the major points right here, all right? So let it settle down. Take the stopper away. It's going to form in 2 layers. So the reaction happening here is the benzoic acid reacting with sodium hydroxide, of course, all right, to forming the benzoate salt, sodium benzoate salt. All right, let's waiting for the 2 layer to settle down. Swirl a little bit. I bring it closer to the camera. Now you can see there are 2 layers, right? The interface a little bit cloudy there, but you can see 2 layers. So now the top is going to be the aqueous layer, the bottom is the methylene chloride layer. Why is that? Because of their density difference, right? Methylene chloride is more denser, okay? So in terms of our desired compound, para-dichlorobenzene is relatively nonpolar, dissolved in the methylene chloride layer. Benzoic acid reacted with sodium hydroxide become a salt, dissolve in the top layer. Now this is the part we separate the two layers away from each other. All right. So the bottom layer is the methylene chloride layer, contains the para-dichlorobenzene. So I need to measuring this beaker, empty beaker first. So zero the balance. All right, 50.10. Let's record it down. 50.10 gram. That's the empty beaker. This is going to be collecting the bottom organic layer. The beginning can be fast, but when it's approaching the interface, you better slow down. We're getting there. All right, here we go. All right. So in this beaker, it's going to be my organic layer with methylene chloride solvent as a majority and para-dichlorobenzene. Next is to remove methylene chloride, because the methylene chloride's boiling point is about 39, right? Para-dichlorobenzene is much higher than that. So if I leave on hot water bath like this, the methylene chloride is going to evaporate away over time, leave only the para-dichlorobenzene behind. And then we weigh the whole thing again. We know how much para-dichlorobenzene we recovered. All right. Let's cranking at the temperature a little bit. Okay. So that's for the organic layer. Now, what do we do with this aqueous layer? We can drain them out too. Remember, here is the aqueous layer contains the sodium benzoate derived from benzoic acid. We talk about separating benzoic acid, all right, but we turn it to a salt. Apparently, we need to get it back, all right? All right. Let's take this away. So this is our aqueous layer. I'll leave on the side. At the same time, the organic layer is bubbling. Methylene chloride is bubbling away. It may take a little time. Now, what do we do with the aqueous layer again? It's benzoic acid. It's benzoate salt now. We need to recover, turn it to benzoic acid again. How do we do that? We're going to add in concentrated hydrochloric acid into it. And then the benzoic acid going to be regenerated again. How do we know it's acidic enough? We're going to add, litmus paper inside, or to test it. Basically, we're trying to check the pH of this solution after we added the HCl. Smoky. All right, let's do it very quick. Okay. So as you can see, the beaker just turns to cloudy very quickly. Just quickly, just promptly adding acid because the benzoic acid crashing out. All right, just make sure we add enough acid. Let's check in the pH. So this is the litmus paper. It's a little hard to see the camera, but it turns red, which is a sign is acidic enough. Double check. Yeah, it's red, right? That's acidic enough. All right. So the next, we need to cool this aqueous layer with ice bath. So ice bath is just ice and water in a bigger beaker, and we leave this smaller aqueous, the one we need to cool down, just put on top of it. In this way, hopefully more benzoic acid crashing out. And later on, we're gonna collecting the solid by vacuum filtration. All right, so that's it for now. All right, welcome back to the second part of separation by extraction. So the little beaker on the hot water bath is almost drying up. So I'm gonna using a towel to soaking away the water on the outside, and then I leave the hot beaker on the wire gauze, let it cool down on its own. All right. At the same time, our benzoic acid is ready. Okay, it's cool enough. Here is the para-dichlorobenzene, of course. So now we're gonna collecting this the benzoic acid as solids here by so-called vacuum filtration. How do we do that exactly? You need a suction flask, a Bichner funnel, of course, need a filter paper inside the funnel. All right, just leave on top of it. And then I'm going to secure the Bichner funnel on the clamp. I'm going to lower it down. And the sidebar of this suction funnel is connecting to the hose, to a vacuum hose tubing, to the sidebar, it's hard to see, to the sidebar of a tap. So as soon as I turn on the water very fast, it's going to generate some vacuum. All right. Top. Push a little bit down. And then before you start to do the experiment, you need to wet the filter paper. And then just pour your solid mixture, solid and water mixture into it. Some leftover benzoic acid in the beaker. Use some cold water to wash them away. Then I'll move around. Grab a spatula. Move a little bit. Remember, you need to recover as many as you can, right? All right, let's keep doing it. Ice cubes on top of it. Take them out. Let it keep vacuum drying for like 5 minutes. But here, the vacuum here is so strong, it's gonna overflow. So I'm gonna stop right here. I'm gonna pull this breaking from the vacuum, from the hose, on the tap, and close the tap. All right. Take the hose from here too. So now you can see, harder for you guys to see, some little cake on the top of the filter paper. We need to scratch those off. All right. You may think this benzoic acid is dry enough. Actually, no. So we're gonna using a bigger filter paper, fold into half, semicircle. We're gonna transfer those solids, which is benzoic acid, the wet version, from little cake from the filter paper to this big filter paper. All right, that's enough. Some of the on the tips of this spatula. A little bit hard to recover. All right. And then what you do is to just squeeze it to suck the water away as much as you can. Okay. All right. One time of drying actually is not enough. We need to find another filter paper, big one, fold into half, and further dry it again. As you can imagine, transfer from one filter paper to other, we lost some because they always lose some sticking to the previous one. So we dry this thing again. Try it by just simply squeezing. We're going to remove most of the water away, not all of them of course, but assuming this is dry enough. Alright? Alright. So now the next we need to using a balance to weigh how much benzoic acid we recovered from here. Balance again, we're using a weighing paper, right? Fold into a corner, fold into along the diagonal, on top. When number stabilize, zero it. Check your solids of benzoic acid right here. Transfer over. Alright. And the number reading is 0.12. .21 grams of benzoic acid. Yeah, now this guy is cooling down, which is the para-dichlorobenzene. All right, see, it's solidifying into a solids, sticking to the beaker, of course. But remember, we pre-weighed this beaker earlier, right? So now we just weigh the whole thing again. Zero the balance, of course. All right, 5193. Right? So, by subtraction, you figure out how many para-dichlorobenzene we recovered. All right? So, that's it. That's it for separation by extraction. You need to calculating the recovered yield for benzoic acid and para-dichlorobenzene. All right? Do the calculation by yourself. And that's it. Thanks for watching. I hope you really enjoyed today's lab. All right, bye-bye.